Suppose that you're looking down at a merry-go-round. You're looking from above like a seagull looking for a target. And what you see down there on that merry-go-round is a little red-headed kid and a little blue-headed kid. And the question is, which of those kids experiences the greatest centripetal acceleration? Now remember, centripetal acceleration, the steering wheel acceleration, is given by the formula v squared over r. And by v in that equation, we mean the tangential part of v. The part of v that's actually going in the circle. Okay? Now, the question is, which of those kids, the red-headed kid or the blue-headed kid, is experiencing the greater centripetal acceleration? So with your clicker, tell me. Okay. Let's see how we did here. Whoa, we don't know. We don't know. And folks, that's okay. Because when I write centripetal acceleration this way, it's kind of confusing. The blue-headed kid has a bigger velocity, tangential velocity, but the blue-headed kid also has a bigger radial distance, r. And one of those is trying to make that acceleration bigger. One is trying to make it smaller. So let's look at it another way. Let's use the help of, these are the Svensson brothers. They're identical quintuplets, if you'll believe it. And this fellow's name is Sven Svensson. This is his brother Sven, his other brother Sven, his other brother Sven, and Sven. Not much originality in that family. Now, they skate in a perfect line. And that means that this Sven has to skate faster than this Sven. And this Sven is just doing this. You know, he's not very talented. Now, my gut's telling me that this Sven has to skate twice as fast as that Sven, because he's twice as far from the pivot point. Let's see if we can prove that. We can prove that with the operational definition of angle in radians. If we look at what those different things mean, the S is the arc length that this Sven travels. The R is the distance that that Sven is from the pivot. And the delta theta is the angle between the line and where they started. Now here's the thing. The S is different for each Sven. The R is different for each Sven. But the theta is the same for each Sven. So if I rearrange that equation by multiplying both sides by r, and I divide both sides by time, the arc length divided by time is the tangential velocity. The angle divided by time is the omega. Here's the thing. If they're going in this line, the omega is the same for every Sven, including that one. But if someone is twice as far from the pivot, they're going to have twice the linear velocity, the tangential velocity. So we've proven that this Sven has to skate twice as fast as that Sven. Now if we go back to our little red-headed kid and blue-headed kid, and we rewrite that formula in terms of omega. Well, V tangential is just R times omega. And so I plug that in for V tangential. I square everything inside the parentheses. I divide by R. And I get this formula that makes it obvious which of those kids has the bigger centripetal acceleration. The omega is the same for the red-headed kid, the blue-headed kid, and indeed every kid on that merry-go-round. But the further you are from the center, the bigger your centripetal acceleration. Now, in order to have that centripetal acceleration, there must be some net force, we call it a centripetal force, inward. In this case, it would be holding on to the bar, or the friction that's keeping them on at their feet. But mark my words, you get this thing going fast enough, that's the kid that flies off first. I know, I've got grandchildren. Oh, you're a mean guy.